assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Hello everyone, this is Ricky, and today we're working on problem 55 from chapter 22. We're told that hemoglobin exists in two forms: oxyhemoglobin, HB, and deoxyhemoglobin. Oxyhemoglobin is bound to oxygen and is a low spin complex Deoxyhemoglobin, on the other hand, bound to water and is a high spin complex. Now, given this information, we're using crystal field splitting to explain whether is a strong or weak field ligand, and also explain why oxyhemoglobin has a red color or gives arterial blood a red color, and why deoxyhemoglobin gives a dark color to venous blood. All right. So first, let's categorize the strong or weak field ligand. So we know that oxyhemoglobin is bound to oxygen, and that it is a low spin complex of ligands. That low spin complexes are strong field ligands. Now to explain colors. So first off, remember that crystal field splitting energy is equal to Planck's constant times the speed of light over the lambda of max absorption. Remember that is the color that we see is the wavelength of light reflected back. And the wavelength of light that are typically reflected back are the opposites of rather the complements of that wavelength on the color wheel. All right. So let's explain the red color of arterial blood. So low spin complexes tend to larger crystal field splitting energies. Crystal field splitting energy is inversely proportional to the wave of max. And so a smaller wavelength of light, such as blue, so absorbs small wavelength and reflects larger ones, such as red. All right. Next up, deoxyhemoglobin is bound to H2O. Water is typically considered a weak field ligand. So that is smaller. Delta is inversely proportional to wavelength of max absorption. So we probably are absorbing longer wavelengths and reflecting back shorter wavelengths, which is blood can appear dark or almost bluish tinted. It was helpful, and I'll